Hey guys, today is Friday, January 26th, and we're going to continue the unit on dilations. First, we have a question here that has to do with what we went over yesterday. This is a starter question. The pentagon MNPQR is shown on the coordinate grid. Pentagon MNPQR is dilated with the origin as the center of dilation using the rule XY, 1/4 X, 1/4 Y to create pentagon MNPQR prime. See the little notations there? That means prime. That's the dilation figure. Which statement is true? We have the new pentagon is larger than the original pentagon because the scale factor is greater than 1. We have the new one that is smaller than the original one because the scale factor is less than 1. We have the new one that is smaller than the original one because the scale factor is greater than 1. And lastly, we have the new one that's larger than the original because the scale factor is less than 1. Okay, let's talk about what we learned yesterday. We learned the algebraic rule is written as such right here. And we know that this number here, 1/4, is the scale factor. Yesterday, remember, we talked about the scale factor. If it is greater than 1, the image gets larger. If the scale factor is between 0 and 1, the new image gets smaller. So knowing that, which ones can we mark off? Since this is 1/4, it is between 0 and 1. So we know we can take off the larger one here and the larger one down here. So it's going to be either G or H. And let's read this last part here. G says because the scale factor is less than 1. H says because the scale factor is greater than 1. Well, we know the answer is going to be G because 1/4 is less than 1. This is the type of question you're going to get on the STAR test based on what we did yesterday. Okay, on to today's, we've got more stuff from yesterday. Let's do some practice from yesterday. This says identify the scale factor used in each dilation. I have a question here and here. You can pause the video, do your math, and then come back and I'll go over the answers. Okay, for question 17, let's compare BD to BD prime. So, BD has 2, BD prime has 1, 2, 3, 4, 5, 6. So we know the rule is to put the new figure over the old figure. So we have 6 and 2. 6 divided by 2 is 3. Hopefully you got the scale factor of 3 for number 17. Number 18. Okay, we cannot use these diagonal lines on these triangles. So we're going to have to use A to B and A prime to B prime. So this is our new figure because it has the prime marks. So we know it's smaller, and that means the scale factor is going to be between 0 and 1. So let's see what we've got. 1, 2 here for the new figure. 1, 2, 3, 4 for the original figure. So 2 divided by 4 is going to give you 1/2, or as a decimal, 0.5. Hopefully that's what you got for question 18. We talked about this yesterday, algebraic representation of a dilation, okay? For the scale factor k, the rule would look like this. xy would be written as kx, ky. And here's our example. The scale factor is 3. Knowing that, we can write the rule as xy will be 3x, 3y. And we know since the scale factor is 3, this is going to be an enlargement. So today we're going to talk about graphing dilations. You can find points on the dilated image by multiplying the x and y coordinates of the original figure by the scale factor. So let's do an example. Here's our first one. Graph the image of ABC after a dilation with the origin as its center and a scale factor of 3. What are the vertices of the image? This is what you do. You take the ordered pair of A. So we have 1 and 1. So A is that point is 1 and 1. B is 3 and 1. 3 and 1. And then for C, we have 1 and 3. 1 and 3. They tell us our scale factor is 3, right here. Okay? So you multiply your x and y coordinates by 3. So 1 times 3 is 3, and since y is 1, it's the same thing. 1 times 3 is 3. You do the same thing for B. 3 times 3 is 9. 1 times 3 is 3. And then for C, you do the same thing. 1 times 3 is 3, and 3 times 3 is 9. So now you have your 3 new points of your new triangle, and you can plot those in, 3 and 3, that point would go here, and then you would point B and C. You would graph B and C, okay? So you have your new vertices of the dilated image right here. When you graph the image, it should look like this. There's your A, B, and C. And since in this original problem they told us the scale factor was 3, so we knew before we even graphed this that the new image needs to be larger than this triangle. And it was. So everything works out. Let's do another one. This one says graph the image of x, y, z after a dilation with the scale factor of 1/3 and the origin as its center. Then write an algebraic rule to describe the dilation. So here's your steps. List the coordinates of the vertices of the pre-image. So you can label x and put 3 and 3. Then you can label y and find those points, and z and find those points. Once you do that, you'll multiply your x and your y by 1/3 to get your new coordinates. After you do that, you'll draw the new dilated image, and then you can write your rule. You know the scale factor is 1/3, so it would be easy to write that rule. You can pause the video while you do your math. Okay, hopefully you got a picture that looks like this. Okay? I'm sorry, a picture that looks like this. This was your original picture. There it is. There's your original picture. And then since you knew the scale factor was 1/3, that is between 0 and 1. So you knew that the new triangle that you were going to draw was going to be smaller. Okay, let's try another one. Now that you know how to do the math, we don't even have to draw a picture of it, but you can if you want to check it. This one says rectangle has vertices P, Q, R, and S. The origin is the center of dilation, and X, Y is 1/3 X and 1/3 Y. So we know what are the vertices of the dilated image. In this question, they didn't write out your exact scale factor, but you know what the scale factor is from this algebraic representation. So list your P, Q, R, and S coordinates and then multiply by the scale factor. After you do that, you'll have your new coordinates for the new image. Pause this video and you can check your math. You can do the math and then come back and check. Hopefully you got for P prime, you got 2, 2. For Q prime, you got 2 and -2. For R prime, you got -2, -2. And for S prime, you got -2 and 2. We got one more question for you. This will be a rule question. Can you write an algebraic representation of a dilation that has a scale factor of 0.45? Okay, hopefully you wrote something like this. Oops. Sorry guys, it's a little crooked here. There we go. There you go. Hopefully that's what you put. It really is that easy. Okay, now you can get your handout for your homework. Hopefully you'll finish during the class period and not have any this weekend. Thank you for watching.